All right, let's take a look at this first question. I'm really a fan with exponents of just writing things out the long way and just really seeing what I'm working with here. So I'm going to do that here. I think what you'll see is that when I write it out the long way, you're going to see that there's a pattern. It's not, you don't have to write it out the long way every time, but I think it's helpful to see. I'm actually going to start at the back because the numbers end up being a little trickier. So look, I'm going to put the B here. This is the B on the bottom. Look, and on the top I have 7 B's. 2, 3, 4, 5, 6, 7. Okay, now for the A's, look, I have 3 A's on the top, and I have 5 A's on the bottom. Okay, now you might already remember what's going to happen here is, right? Like this is B divided by B, that's just 1, right? This is A divided by A, that's 1, that's 1, that's 1. This is all just like basically multiplying by 1. Now with the 15 and the 3, look, I'm going to write the 3 on the bottom. 3 is prime. I'm going to write the 15 as 3 times 5 because, look, we're actually just doing the same thing, right? We're saying, oh, like I can divide by 3 here, right? 5 divided by 3 is 15. Sorry, 15 divided by 3 is 5, excuse me. And so if I just write the 15 as 3 times 5, I can see like, oh, this 3 divided by 3 part, that's just equal to 1. So now if we just take a look and see what I have left on the top and the bottom. On the top I have 5, right? And I have 1, 2, 3, 4, 5, 6 B's. And on the bottom I have just 2 A's. And I would write it like this. Okay, now if we take a look and just kind of look and see what's the pattern, well, I basically simplified this fraction, which is I divided the top and bottom by 3, right? So I got 5 over 1. Here I said, oh, I have 3 A's on the top and 5 on the bottom. So if I cancel them out, right, I can kind of picture it without doing it, that I'm going to have 2 A's left on the bottom. And if I have 7 B's on the top and 1 on the bottom, I'm going to cancel out 1 and have 6 left on the top. But this is it. This is my answer. Okay. This next one's a little bit more complicated. Okay, so, but I would honestly, I would kind of start off pretty similar. I really just like this idea of writing it out with exponent rules. But the thing that's going to hold me back is this right here. This negative exponent. What happens here? Okay, what happens is these two y's are not happy down here. That's why the exponent is negative. That means, that y does not want to be here. It wants to come up to the top. Okay, so when I write this out, and I'm going to write it out, I still have 3 over 4. And 4 is 2 times 2. That's not going to cancel with anything. I'm just going to leave it written as 4. Right? This is actually a fraction that doesn't simplify. Now for the x's, I have x times x, and on the bottom I have 5 x's. Okay. Now here, look, I have these 3 y's, and then look, these 2 y's that were on the bottom, remember, they didn't want to be on the bottom. They actually wanted to move and come up to the top. Okay. So the y's move up. Right? And I actually noticed there's some x's that can cancel. Okay? So now what this ends up equaling, look, and I'm keeping the power of 3. I haven't even touched that yet. But what's inside this parentheses is there's a 3 over 4. That's not going to simplify. There's 3 x's left on the bottom. And there's 5 y's on the top. Okay? So what have I done? I've not simplified this, so I've not even touched this. I've canceled out 3 x's here, leaving, 2 x's here, leaving just the 3 on the bottom. And I've moved these 2 y's up, and what they've done is just joined these 3 y's, right? There were 3, and then there were 2 more, and so now there's 5 y's on top. Now I'm going to take it to the 3rd power. And again, look, I'm just going to write it out. Now, am I saying you have to do this every time? No, I'm saying it's helpful to visualize it. But this is what this means. And I know it's so annoying to write it out, but realistically, this is really not taking me longer than 15 seconds, so it might just be worth it to do it. Okay, so here it is. Okay, this is 3y to the 5th times over 4x to the 3rd to the 3rd power. So across the top, right, when we multiply fractions, we just multiply across. So across the top, I'm doing 3 times 3 times 3. That's 27. So on the top of this fraction, I have 27. And then I have 1, 2, 3, 4, 5 y's, plus 5 more y's, that's 10 y's, plus 5 more y's, that's 15 y's. And along the bottom, 4 times 4 times 4. Feel free to use your calculator. You could do it like this, or you could do 4 to the power of 3. Either way, it's going to be 64. And this is x times x times x. That's 3 x's, 6 x's, 9 x's. And here is my answer. Okay, a little bit more steps on this one.